Welcome to today's webinar. The topic today is most frequently asked questions addressed by Dlubal's support team. My name is Andreas Hörold. I am responsible for marketing and public relations in the Dlubal software company. I'm working here for 12 years. I'm responsible for the website, for example, the German and English webinars, customer projects, etc. I will be the moderator and presenter today. My two colleagues will support me and they can introduce themselves.
Hi, I'm Caroline Lessmann. I work here at Dlubal Software in the marketing department. So I'm also responsible for the webinars and newsletter, and I'll be answering your questions today.
Hello, my name is Markus Baumgartel. I'm responsible for customer support and frequently asked questions on our website. And today I will help my colleagues to answer your questions during this webinar.
Okay, thank you for your introduction. Then we can switch off our webcams that the attendees can see the full screen. Some words to your questions. You can ask questions via the control panel on the right side of your screen. You can enter a question here, and my two colleagues will answer you. If you don't get an answer during the webinar, because there are too many, you will get an email afterwards. The other way is to watch the entire webinar and email your questions to info@dlubal.com. Okay, then we turn to the program, RFEM 6, and the first question is, how can I apply moving loads to members or surfaces in RFEM 6? In RFEM 5, we provided the RF Move add-on module, but there's still no corresponding add-on for RFEM 6. You can use a workaround. We programmed a script and we provide it on our website. Let's go to our website, dlubal.com, and under news and events, you find the webinars. And this is today's webinar. We uploaded 3 script files here. One for generating moving loads on sets of lines, then one for loads on members, and one for loads on sets of members. I used the first 2 files, and after I downloaded them, I can copy them in that folder here. That's quite important. The C drive, there is RFEM 6 installed on my computer. Then user, that's my name, app data, local, Dlubal, RFEM 6, 6.202, that's the version, and user scripts. And those are the 4 files in that case, the JavaScript file for the line set load and the XML file. And those files must be copied in that folder. And then you can use them when you can find them in the script manager here under user scripts. Before we start, we have to create a line set. Those are single lines, and we have to connect them with creating a line set. So with the control key, I can select all the lines. Then by right click, I can use the function create line set. Line set number 1 is created. Okay, and I can run the script, the first script. I have to enter here the load, the nodal load, 1000 Newton, 1 kilonewton, that's quite okay for our trial. Then 10 steps and line set number 1. So those load cases are created. We can find them also here, and I can click through the single load cases, and the load is running over the line set. Let's repeat it for this member here. The member number is 1. Then I run the script. This time 2 kilonewton, 10 steps again, member number 1, run. Okay. And the 2 kilonewton are running or moving over the member. Okay, yeah, just download the scripts from the website and you can try it by yourselves. In the next days, we will also upload the model files on our website, and you can try it also with these models. Okay, also the whole webinar we will record this webinar, and you will find the recording on our website, on the same website that I showed in the next days. Okay, to the next model and the next question. Question is, when using several scissor hinges, I cannot perform any calculation. However, I cannot find any reason for it. I use the transparent model. It explains it a little bit better. Yeah, a scissor hinge can be used to model the crossing of continuous member. Yeah, for example, here, 4 members are connected to one node, and the members, these members here, transfer moments in their continuous direction, but not to the main member pair here. Yeah, and only axial and shear forces are transferred in this node. Okay, let's turn back to the wireframe model. So there are the first hinge. I double click on the member and hinges are checked. And that's why we can see this dialog here, and we can edit the hinge. So the scissor hinge can be only used in the global and also a rotated coordinate system. Yeah, and we check here phi x and phi z. That means that the moments around x and global z are not transferred to the main member. Okay, and scissor hinge is also checked here. Then let's take a look at the end of this member. Here, scissor hinge at the end and with the same conditions. Okay, let's calculate all. Yeah, and we get this warning message. That's a numerical problem. We have to use exactly the same member hinge for the scissor hinges on both sides. That means I have to use on the right side also the hinge number 1. Okay, now I have the same hinge on both sides. Okay, now we get the right result. You can see the supporting moment here from the secondary beams. No torsional moment on the main beam. Yeah, and that's the correct results. Yeah, the solution was the same hinge or scissor hinge on both sides. Okay, then we turn to the next model and the next question. How can I create a contact between 2 surfaces as quickly as possible. Yeah, you can see these two concrete slabs. It looks like this one lies on the other, but I showed the thickness in the model. If I change to the wireframe model, you can see there's no connection between the two surfaces. But it's quite easy to connect them with a special object here on the left side in the navigator data, surface contact, and with right click, I can select new surface contact. So you can select a group of surfaces for both sides. It's not necessary that the surfaces has got the same dimensions or number of lines. It doesn't matter in RFEM6. I select the two surfaces and I have to create a new surface contact type. There are different options for the contact perpendicular to surfaces, full force transmission, failure under compression or failure under tension. And for the contact parallel to surfaces, the full force transmission, friction, etc. I use the rigid friction in that case. And yeah, we can enter a friction coefficient here, for example, between concrete or between two concrete surfaces, or if you want to consider that the slabs or the surfaces can slide, you can enter a very small friction coefficient here. Okay. Then let's calculate all. Okay, and now we can see the surfaces are connected and we have got the same deformation on that point here. That means the upper surface lies on the surface at the bottom. Okay, then we turn to the next question. Is it possible to generate models like in RFEM5? In RFEM5, we had got a lot of model generators. We have different ways to do that in RFEM6, for example, with the scripts. There are different examples here for how and so on. And you can use these scripts here for loading and loads for lines, solids, etc. And you can program your own script. If you don't have any knowledge in programming, you can use the Dlubal blocks. You can find the Dlubal blocks here on the left side above, Dlubal center blocks. I can move them from my other screen. Where are beams, columns, arced beams, trusses, 2D, 3D, frames, multi-bay frames, tapered frames, hulls. Here a typical hull frame, then a complete hull, 3D, or for timber structures, horizontal beams of roofs and so on. Let's try it with a 2D truss, maybe the first one. Or I repeat it. Okay, I open a new file. Okay, I call it 1. that we don't override this model here. So, okay, then let's open the blocks again. Then trusses 2D. Yeah, and there are different parameters. Here, for example, for the structure, you can select different cross sections, yeah, different materials. For example, I have to select steel here. Then I can change the dimensions here. All is possible. Okay, and if I apply here, the model is created, and you can add nodal supports or loads and design this truss. Okay, then we turn to the next question and the next model. This model. Question is it possible to import support reactions as loads in another RFEM model? Yeah, that's not possible at the moment. We are working on it, but until it's finished, you have to use another way. I would like to show that. So that's the tower wind load case, and let's take a look at the support reactions. And we would like this support reactions to a floor plate. And I open the model. Yeah. And on these lines, we would like to create loads with the support reactions from the tower. So let's turn back to the tower. We go to the table, then static analysis, results by line, the wind load case, and we would like to transfer these loads here, pset. So we have to export the data in an Excel sheet, and the line number 7 and 36 are interested for us. So that's line number 7 and line number 36. Yeah, we would like to create only this 2 line loads on the foundation plate here. So then I have to do that on one screen. If you have got 2 screens, it's quite easier, but I can only do that on one screen that you see all. So then line load, not uniform, but varying. So in Z direction, and we have to fill out the table here by copy and paste. So number 7, the X values, Control C, Control V, and the values in Z direction, Control C, Control V. Okay, the first line load is created. Let's do it again for this line here. So, line load, varying. So, and we have to copy and paste the X values and the load in Z direction. So I think it takes not too much time. It's quite okay. It's only a workaround. We will implement the load transfer, but it will take still some time. Okay, then we turn to the next model and the next question. Question is, how can I print the internal forces and moments sorted by cross-sections and clearly arranged in the printout report? Let's take a look in the design situation number 1 and the internal forces and the normal forces, shear forces, MY forces, etc. Let's take a look at the table, the static analysis, results by member, design situation 1, and internal forces by section. So, and if I scroll down, you can see it's a very, very long table. Yeah, and I would like to shorten it. So I can do that with that button here, show results, result table manager. Here on the left side, the internal forces by section, and I can deselect something and we can take a look at the table. Yeah, it's a very short table now, only the maximum internal forces for every cross section. Okay, I think that's not enough. We have to use another selection here. And we can check it, and I think that's quite okay. The maximum for the normal forces and Y forces, etc. And that for every cross section. I go back to the table here. Yeah, maybe one hint. If you want to print out the member starts and member ends values, you have to select that here. Maybe for the design of connections. If you don't do that, for example, in our program, but in another program, I would select these two checks here. Okay, I would like to print only that table here on the printout report. Here, both on the left side, I create a new printout report. I deselect all and select only the members' internal forces by section. And if I check this here, and I also select this, then it takes over the settings that I did in the table in RFEM. Okay, I selected design situation number 1. Oh, and then I can save and show. The table here in the printout report. Yeah, as you can see, 2 pages. Yeah, and if you like, you can select other or do another selection. Yeah, but you know the workflow now. Okay, then I turn back to the program and we come to the next question. Is it possible to enlarge the display size of design formulas in the printout report? I go to the steel design. I designed only one member here, that column here. It's only an example. And if I would like to show the design checks, I can double click here or use that button, design check details. And that's a new feature in RFEM 6. You can see here the formulas and the equations from the standard and so on. And you can print that in the printout report. Can open the printout report, or it's already opened. So, and those are the formulas. Actually, it's not wished to change the size here. I think it's large enough, but we got the question, can we enlarge the size? There's this trick. By a right click, you can press here, edit, and go to the source code. And if you scroll down, and before that text block here, you can find that line here, print font size, and you can change the font size. I change to 12. Okay. And the font size is enlarged now. Okay, then we turn to the next and the last model and the last question. Is it possible to analyze stresses of welds between surfaces using RFEM 6? Yes, that's possible. I already created line weld joints on the flanges here. Let's do that for the web together. On the left side here in the navigator data, you find the types for lines and the line welded joints. I create a new line welded joint. So then we find the joint types, the butt joint, the corner joint. On the right side, you can see the graphics, the lap joint, and the T-joint. Then single bevel, double bevel, single J, double J, single filled, and double filled. That's what we use. The weld size, okay, 4 millimeter, and we have to assign the line and the surfaces. So this line between those two surfaces. Okay. And now you can see the pointed line here. That's the line welded joint number 2. Let's calculate all. I have to calculate I have to do the stress strain analysis. That's the add-on that is necessary for the design of line welded joints. Okay, I calculate all. So then we go in the table stresses in line welds. And you can see the stresses in the line welds on the left side in the navigator results. You can click through the single stresses, the sigma W, tau W, tau parallel, etc. Okay. An additional hint, we present a webinar in 1 week, the same time on Thursday, and it contains only the add-on stress strain analysis and also the line welded joints. I think you have already got an invitation. If not, you can take a look on our website and register there. Okay, I would like to show the website again. Maybe I can show you the webinar next week. Also under news and events, you find the webinar, stress analysis on surfaces and members. Okay, then under support and learning, you find the frequently asked questions. you need some help, you can enter a keyword here. Yeah, for example, template, it's often asked. For example, how can I save my preferred settings as a template in the display properties? And you find the answer here, or with images, you click on more, and so on. You can also use our chat, right at the bottom, or you can write us an email, and so on. Yeah, and you can find our free full trial version here at the top of the page. RFEM 6 and RSTARP 9, R section, RWin 2, and so on. RFEM 6 and RSTARP 9 contain all add-ons. You can use full versions for 90 days. You can download the used models in today's webinar and the scripts and so on, and try all by yourself. Okay, that should be all from my side. Maybe one an additional hint: when you leave the webinar, there's a small survey. It takes maybe 1 minute. Would be very nice if you answer the questions. It's quite important for our quality management. Just note that the worst score is 1 and the best score is 5. Yeah, that's all. I have to say thank you for your attention. Thanks to my colleagues for answering the questions. I wish all a nice rest of the day, and maybe we meet each other in a future webinar. Bye-bye.